Right then guys, we're just about to start with the aluminium piece that will be the backing piece for the X-axis scale. And before I start doing anything with this in the mill, I've just had it in the vise, basically been over the narrow edges in a draw filing fashion with the file, followed that up with a bit of emery cloth sat on the file. And this isn't about removing any material as such, it's just to get rid of lumps, bumps, dings, bits of material that's stuck to the surface, that kind of thing, as it comes. And I've got a piece here as a prime example. This is one of the offcuts. In fact, it's the offcut off this bar, and I don't know whether the camera will pick it up, but there's all bits of lumps of material stuck to it and dings here and there, and all that kind of thing. There's a nice lump of something stuck on there. Don't know what that is, but that gives you an idea. So before I do anything with this, I just wanted to make sure that was clean and not for the aesthetics. This is just because I'm going to be locating a precision device on here, expecting it to be precise, so the best base I can give it is going to pay dividends in the long run, hopefully. So we've just cleaned it all up, deburred the corners, made sure it's nice and smooth, and then done the same thing on the broad faces as well. Just a gentle draw file with a file, and then just a gentle wipe over with some emery cloth, again not to remove any material, but just to remove any lumps or bumps and dings and things like that. So that's now in a nice state. We're going to set that up in the milling machine and start the machining. So basically first job is to square both ends up, and then we'll take it from there. So the backing plate is now in the vise, ready to just have the ends squared up. I'm set up, ready to go with a 12mm end mill on this end. I just thought I'd have a pan out and show you what I've done at this end. So I've got a screw jack just sat on a block, and it's not really doing anything. I've just brought it up just a touch, just to hopefully take some of the ringing out of this, because it will ring a bit when I cut this. I'm not taking a lot off. I don't need a fixed length on here. And even if I did, the only thing I've got to measure it with really is a tape rule. So it's not accurate, it just needs to be long enough to span the length of the axis to fix it, and also to put the scale onto. So we'll take a light cut on this end, I'll bring you in closer, we'll clean this end up, spin it round, do the same thing with the other end, which I won't show you because it's identical, and then we'll load it back up and we'll start marking out for holes to go in to hold the cover plate in position. And then once they're fixed in place, or once that they're put in and I know exactly where the cover plate's going to sit, I'll then offer the scale up to it, and I'm just going to measure from each end to make sure I'm uniform distance each end, and then we're just going to mark through from the scale onto here. We'll scribe through, and we're just going to put the holes in for the scale by eye. Well, not by eye, but by marking through from the scale. Right then guys, first opportunity really for me using the full extent of the mill really with this job. So I've squared both the ends up, so we've put the aluminium piece back in the vise, and I've kind of set it up. I think I'm going to get to 3 of the holes out of the 4 that I need to put in here. I don't think I'm going to span all 4, so might have to do a bit of jiggery pokery for the last one. So effectively I've loaded the guard up to the front of the aluminium so that that's flush all the way down, end to end. I've measured in with a 6-inch rule, and I've got 14 3/4 millimeters in from both ends to the start of the guard, so I know the guard's positioned centrally this way about the aluminium base plate. What I've then done, you can see I've got that clamped with a couple of toolmaker's clamps. I've found the twin brother of the screw jack that I got at the other end, so we've got this one set up now, just giving some support at this end. I've got no idea where I acquired these, but acquire them I did, and very useful they are, so we'll carry on with them. I've got an 8mm spot drill in the milling chuck. The only reason I've got a spot drill in is because I don't have a centre drill long enough or slender enough to get down the side of this guard. Not quite sure how well this is going to go, if I'm honest, but we're going to give it a shot. So we're going to drill spot through. I've eye-sighted centre line this way on my y-axis. We're going to spot through 4 holes, and then I shall probably finish all of this off on the pillar drill. So we'll open the holes in the guard out to clearance on M4, and then we're going to drill and tap M4 in the 4 positions for a cap head to clamp the guard on. There is 2 holes, one at each end, already pre-drilled into the guard, but they're absolutely massive. You know, they take up the full flange width of this, so there's, you know, they're next to useless. There's nothing I can put in there other than trying to shape washers and things to fit, which just will look horrible. So we're just going to ignore those 2 holes, put 4 purpose holes in, and put M4 cap heads in. So I'll bring you in, we'll give this a shot with a spot drill and see what happens. Right, we're lined up on our first hole. I've just eye-sighted against my marker pen line there. That was fairly uneventful, which is good. X-axis power feed on the shopping list, or the making list. This one might be a bit more eventful because it's a bit looser, but we'll see what happens. So you get the idea. I'll do the other 2 and bring you back when we're making all of that right, either on the mill or on the pillar drill. So we're up on the pillar drill now. I've got a centre drill in, and I'm just going to pick up my dots that I've gone through with the spot drill on the mill and just put a proper centre in with the centre drill to follow that through with the tapping drill size. That's my 4 holes picked up, so we'll just get set up now for the tapping drill. So we've got a tapping drill in now for M4. We're just going to pop those 4 holes through. I'll do a couple on camera, do the rest off camera, but you get the idea. So we're just going to drill those 4 holes through, then we'll countersink them all and tap them all M4. was swarf. Nope, it wasn't swarf, it's another blunt drill. Welcome to John's workshop. We'll take that drill out and we'll grind it up and have another go. Right, shall we have another go? Oh yes, that works much better. Just to clear this up, I absolutely know that I'm showing bad practice here, and I apologise for that. This bar should be clamped to the table. You know, holding stuff like this in a pillar drill is not the right thing to do. If it grabs, things can go south very quickly. So I'm confident doing this. You know, this is a long length of bar. If this was to grab this with this drill, it would just break the drill, or it would stop the belts, because this drill just doesn't have the power to overcome my strength at this long distance away. So, but you know, if you're doing this, if anybody else is doing this, especially if you're new to this kind of thing, don't do what I've just done. If you look at my previous video, I did a bit of work on the pillar drill, and you'll see I used a G-clamp to clamp the workpiece to the table. If you can't do that, try and put it in a vise of some sort. But yeah, don't do as I do as I say, as the old saying goes. Right, okay, we're just going to countersink those 4 holes now. I'll do that off camera, it's not that exciting. And we'll drop 4 M4 threads into those, and then we can start marking out for the holes that need to go in for the scale to attach onto this. So I'm just tapping the 4 holes in this plate now for the screws to hold the cover plate in place. It's M4 and I've got 1 M4 tap, and this is it, and it's not the best, but I think it will get us through this operation. This aluminium's really, or can be, gummy and sticky, so, and you can feel that in the holes. It doesn't feel nice, it doesn't feel like it's cutting the threads, it feels more like it's forming them, rolling them. I think this tap's not the best, but it's just about doing the job. So that's one for the shopping list when I remember, is to get myself some more smallish taps, probably M4, M5, M6. I've got a few M6s, but anything less than that, I've only got 1 or 2, and they're not, you know, they're 20 odd year old, they're not very good. So that's the last of the 4 holes. That's an M4 cap head. It's a really good tight fit in there actually, so it's, yeah, it'll do the job fine. That's going in okay. So not the best, but we've got there in the end. So that's those 4 holes put in for the guard to go on. The next job now is to assess where the scale's going to fit and get some holes marked out where the scale's going to go, and also where my two end points, my two end fixing points need to be to fix it to the front of the x-axis scale. So we'll give it a clean, we'll lay all that out now, make some marks on here, and then we'll get the holes put in for those two sets of fixings. Alright guys, we've got our scale on top of the aluminium plate now. I've set my distance down from the top edge down to the top of the scale, which is effectively the distance plus a little bit of clearance of this step on the guard, so I know that that's going to fit nicely, and I've got a bit of spare. I don't want it tight up against the scale, I just want a bit of clearance in there, so I've left a couple of mil clearance, something like that. And I've also set with a rule each end off the aluminium rail, so I know that I'm equal about the aluminium plate. So what I'm doing now, and these toolmakers clamps are just literally just the tiniest nip, they're not tight at all, it's just a tiny nip just to stop this moving, just while I scribe down through with my Suston punch again, that's ground to a sharp point. I do need to get myself a proper scriber, or make myself a proper scriber at some point, but for now this will do the job. And that'll do. So I've done both ends there now, so that's scribed, and then you can see how this is going to fit now. So the pieces that I made on the lathe before, these are the bits that I match paired up widthwise, will sit between the aluminium rail and the front of the table. This piece that's got the counterbore in the front will sit on top, so effectively I'm going to sandwich the aluminium rail between those two. It would help if you could see what I was doing, sorry about that. Move the camera around a bit, there you go. So yeah, that's the piece that I've controlled the thickness on. They're going to sit underneath at the end of the rail. The piece with the counterbore on will sit on the top like that, with a M8 bolt through the centre, all the way through into the T-nut at the back that I've made into the slot. So effectively one of those sets at each end to hold the aluminium rail. So what I'm going to do is we're going to fix it just at each end to start with, and we'll see how flexible we think this is in the middle, or how unsupported we think it is. You know, it's not under any load, the only weight it's got to carry is the scale, but I'm more concerned about, you know, if you get into a heavyish cut, if you've got any vibration on the mill, is this middle bit going to start sort of wafting around, which it could do under vibration, not a lot, but just a little bit. So I may need to come up with some way of just supporting that centre section, so the biggest span I've got then unsupported will be about 300mm, 12 inches, something like that. So, but we'll cross that bridge when we get to it. We'll get it fixed up at each end first. So the next job now is to get this out of the vise, strip back off, we'll put it on the mill, we'll set it up, and we'll start putting our holes in, ready for the scale to bolt to the aluminium piece. So I'll bring you back when we're doing that. Slight change of plan. For the two holes that hold the scale in place, because I'm just working to scribe lines, I'm putting those in on the pillar drill. So I'm drilling, I've centre popped them, centre drilled them where the centre pop is, and I'm now drilling 4.2 millimeters for an M5 tap. So I've done one hole, I'll show you the other end. So that's got the two holes in each end in the middle of my scribe lines. Next job now, we'll just countersink those, and then we'll get those tapped M5, same as what you've already seen with the M4 holes, so I'll not film that. Then it is actually going back up on the milling machine, because I'm going to slot the holes for the end pieces where we fit the turned pieces that I've made. They're actually going to be slotted so that I've got some movement on that back plate in terms of being able to clock it up. So we'll join you back at the mill. I'll get these two holes countersunk and tapped, and I'll join you back at the mill when we're slotting those end two holes. Right, I've drawn a quick sketch on the board. The last operation on the aluminium backing plate is to put the two slots in either end for fixing to the front of the table. So I've two sketches here, completely separate really. So this is the table itself. I've measured the drop from the top of the table to the top of the slot and the width of the slot, and from that calculated the distance from the top of the table to the centre line of the slot. And then on this side I've drawn my aluminium strip. Now what I want to do is I want this aluminium strip to sit at least nominally a millimetre below table surface. I don't want any interference at all, so if it was smack bang flush with the top of the table, there's a chance that it might be slightly plus and then the vice will be cocked up on it and anything else. So I want this to be at least a millimetre down, so nominally a millimetre shorter to the centre line, and then I'm going to pitch out by 3 millimetres in each direction because I'm using an 8mm slot drill, and we're going to put that slot in both ends as big as that. Loads of adjustment then to get that where I want, and that also allows me, if I decide I want to drop it slightly more than a millimetre, I've got an extra 2mm or 3mm of scope based on the length of that slot that I'm going to put in. So we'll get the mill set up for that now, and I'll bring you back when we're doing that. So we've got the part set up in the vise on a couple of parallels. Screw jack under this end again just for some support. We've had the edge finder in, we've touched on this edge, wound into the centre line of the slot, touched on the back edge, wound into my 23.75 nominal centre line from the top edge. We've got an 8mm solid carbide 2-flute slot drill in there, so we're just going to plunge in and then just pocket backwards and forwards until we've put that slot in. So we'll just crack on with that now. I'll just move the camera so you get a closer view, and we'll bring you back when we're cutting. There we go, that's slot number one. I'm just going to whip this round now, do the same thing the other end, not film it, exactly the same, and deburr the two slots, and then the next job then is to start fitting this to the front of the mill, and I'll bring you back when we're doing that. So I'm just using the new Noga tool that Carl sent me for this, nice and easy. I'm only using one hand's worth of pressure, the second hand's there just to steady it. Really useful tool for deburring, and especially in aluminium you get a really nice finish with it. So that's it, all done, two slots in, deburred both sides, ready to fit now onto the machine. So we're at a point where we're ready to fit, or almost ready to fit, the aluminium backing bar to the front of the X-axis. I've just had a word with myself about even attempting to do that while the mill's in this state in terms of swarf and stuff, but I thought about it again, and really the only bits that need to be clean are the location areas where I'm putting the spacers. and the T-slots need to be cleaned. So I've cleaned the T-slots out, I've made sure this front end of the table's all clean. There's no point going mad cleaning the whole table, because as soon as I've got this thing fitted, I'm then going to be machining more aluminium straight away for the reader, the bridge that I need to build to go into the bottom of the reader. So first thing I'm going to do is just make sure I've got most of my stuff ready that I need. So I'm just going to stone these end faces on the front of the table, just to make sure there's no burrs or anything. There shouldn't be, because I already did this when the mill first arrived. But I'm just going to give those a quick rub with a flat face stone. Just to make sure there's nothing on there that could cause it to be not sitting flat. And we'll just give those a wipe over. They feel good. So the moment of truth. Does it all fit together? Oh dear, well that's interesting. That's a good start. T-nut doesn't fit. Oh yes it does. They are a tight fit. I've made them, well, not a tight fit, but I've made them a good fit, let's call it. So I'm going to need about 5 pairs of hands here. I've taken the 2 axis lock screws out, by the way, you probably see they're missing. If I've got my measurements right, this cap head screw should tighten up long before anything bottoms out. We'll just give that a proper nip just to hold that a minute while we get the other end in. But so far so good. Just roughly line that up with the slot. There we go. So we'll just unknit those now. The next job is to position these centrally about the table length, which is largely going to be done with a rule. Certainly to start with. It's not far away, about 16 mil one end and 16.5 the other. Spot on. Well, spot on with a rule. So the next job now is to position it height wise. And I've got parallel ready at each end. The plan being, I've got a 1mm set of feelers there, and I'm just going to bring those up to touch. And we'll do the same at the other end. And we'll just recheck the first end again, because I'm sure that will have moved, and it has. I've just got a nice feel on that end. just about got a feel on that end, so we'll nip it up like that. I'm not going to clock this one in because I've got movement on the actual readout, the scale itself, and that's the only bit that's really important. I think setting those with a set of feeler gauges underneath the parallel to the top of the table surface is going to be more than accurate enough for this backplate. So the question that I want to know is, and that was my concern, you know, this isn't going to move, certainly not under the weight of the scale that's going to be on it. It's perfectly rigid enough, it should be nice and straight, but the issue I've got is if we get any harmonics in the machine or any vibration, it's going to transfer into this bar and it's ringing like a bell, which is what I knew would happen really. I'll give that some thought. It's pretty rigid. What I might do actually is bolt the scale to it, but again that's bolted at each end, so it's not going to do anything in terms of firming the middle up, but it may take some of that harmonic ring out, so we'll attach the scale and see if that makes any difference. I'll bring you back in a moment. I've got the scale on. Obviously it's not clocked or anything like that, so two bits of news. The first news is it all fits, so that's a good start. And second bit of news is I think I've had a win. So I've obviously tightened the two clamping screws up as tight as I would normally tighten them when I'm fixing it in properly, once it's all clocked in. And all that ringing has disappeared. So I'm tempted to not fanny around. I'll pick that up later. I'm tempted to not fanny around and try and make some convoluted, awkward bracket that needs to go behind this steel piece to the front of the table. It means drilling holes in the front of the table that potentially they wouldn't break through into the T-slot, so that wouldn't be an issue, but it means drilling two holes in the front of the table, trying to drill some holes into the back of this aluminium piece, which I need to strip everything back off. That's not a problem. It's only a few minutes job, but I think that's going to be okay. I think even if I put a bracket in the middle there, it's going to not make any difference to that. So I think it's good enough to give it a whirl. So next job is vice off. Yeah, the next job I'm going to need to take the vice off next and to get a clock on the table. I can't even lift the clock up over the vice because it's too high, so we need to get the vice off, get a clock set up, and then clock this scale in. And before I do that, just want to have a quick look and check to see if my holes on the cover line up and everything fits, which it should do. Yep, that all looks good. So that's it with the cover in place. I think that looks fairly neat actually, and well protected there now. Yep, happy with that. Okay, next job, we'll get the vice off, have a bit of a clean up of the tools and stuff, and then we'll get a clock set up and we'll clock that scale in and get it fixed in where it's going. So I'll bring you back when we're doing some of that. Okay, so I think you can see the clock there okay, so we'll start winding. So we're on 0 at that end. Plus half a thou, plus a thou. Ignore this bit because we're going over the sticky label. need to make sure I'm not getting that cable tight. So we're +3, +4. I'm glad it's out, otherwise you wouldn't believe me. That's the full extent of travel in both directions, hard up against the stop each way, and I'm +10, 11, 12, +12.5 thou at that end. So I'll just get my knocker out, and that's not the right, no, that is the right Allen key. It's this one you're undoing, you idiot. So we've taken that back to 0. Rightly or wrongly, we will find out shortly. -1. So -1 thou at that end. And it dips in the middle. I think the lowest I saw was about -4 right in the centre. So it's obviously the extrusion's got a bow in it. There's nothing I can do about that. There's no other way of correcting that. But at the limits of travel each end I'm within 1 thou. I've done one more adjustment with this and I think I've got it. So we'll just go back the weight so we're on 0 at that end. -1, -1.5 at the start of the label. -3. So -0.5 at that end. I think that's good enough. I'm going to leave that alone. I've checked in the book and the book says for the x-axis no worse than 0.15 of a millimetre, which is 6 thou, and I'm half a thou end to end, and at worst the dip in the centre is about 3 to 3.5, and I think that's just in the extrusion, in this aluminium extrusion. So I think we're going to call that good. We'll leave that as it is. So we'll take the clock off and then we'll start looking at what we need to do in terms of connecting the bridge pieces that I need to bridge to the reader head. So I'll bring you back when we're doing some of that.